possible. My talk is called Building, Testing, and Deploying Android Apps with Jenkins. Yeah, so let's get started. So first, a quick bit about what my connection is to Jenkins and to Android. So I work on the other side of Germany in Cologne for a company called Iosphere. As you can maybe hear, I'm not actually German. I'm originally from Scotland. And at Iosphere, we build mobile applications, plus often the supporting parts, backend, data aggregation, so on. We're also really big fans of Jenkins. So we do stuff like creating apps like Offmaps, which gives you mobile applications and Wikipedia, public transport data, all available offline. And this works because we built our own offline vector rendering engine for maps and for detailed street map data. And this is all built by Jenkins. Behind the scenes, a lot of the stuff, map processing, app building, app testing, data aggregation, it's all done by Jenkins. We also build apps for other customers. For a mobile payment startup here in Berlin, for example, we do a lot of work building the apps, working on custom hardware, firmware, working on security and stuff like that. And of course, built, tested, a lot of stuff's deployed by Jenkins. And also at Iosphere, we have some other more pretty looking apps. Here's an app with a really nice UI for finding hotels. And again, built and tested with Jenkins. Also, we built a backend for collecting all the hotel data and pushing this into the app. We built a backend that's run from Jenkins, and we also built a front end that our customer can use. So they get a nice web interface. They can push the data into the app without ever seeing Jenkins or having to click build now. So this is kind of some of the stuff we do. So yeah, we like Jenkins, but I'm here to talk about Android. So I've been an Android developer myself for about 5 years now, and it's what I spend most of my time doing at Iosphere. So what are some of the challenges that we face when trying to build high-quality Jenkins apps? Well, the first problem is Android. So there's a huge diversity of devices that Android runs on. There's smartphones, there's tablets, there's televisions, there's vending machines, there's watches, games consoles, everything, which is pretty cool. But how does this affect us, as mobile developers? So if I go to Google Play and want to upload an app, I see this page. When I upload my app, and my app normally has certain requirements saying I need a minimum version of Android 4.0, it has to have a touch screen, it needs a GPS, it must have Google Maps installed, for example. And here we see this works out to 3,572 different devices that fulfill this criteria. That's 3,500 devices, completely different models with different combinations of operating system, screen size, maybe some have a hardware keyboard, some not, some have a tiny amount of RAM, some have 2 gigabytes of RAM. So this diversity is pretty cool, but it's a bit of a pain for anyone who's trying to create a consistent app that will work well across as many of these 3,000 devices as possible. So the other problem is developers, or the usual software development process. So writing mobile apps is not hugely different from writing other types of software. We still need to tackle the common problems like runs on my machine, or developers who build on one version of the Android SDK versus people who test with a different set of SDK tools, people who test on one device versus another, this kind of stuff. So, of course, we know that Jenkins can help here, but what exactly are the steps that we need to take to go from our Android code on the one side to happy end users at the other end? Well, the first step with Jenkins is building. There's a building. So of course, we can build our app, know that it's running in a clean environment, and we can do some static code analysis and this kind of stuff. So what do we actually need to build an Android app? Well, of course, the code helps. As it's all based on Java, we need the Java development kit. We need your build tool, whichever one you use. The Android SDK tools, and of course, the Android platform. So Jenkins helps us here by, for example, we have the SCM plugins, Git, Subversion, hopefully not. And that can be automatically set up for you, along with the JDK your build tool, Ant and Maven are built in. There's also a Gradle plugin, which will automatically install that for you. So this is pretty cool. This automates a lot of stuff. But also, on the Android side of things, we have this Android emulator plugin, which has a slightly misleading name. It actually automates a lot of different stuff relating to Android. But this will automatically download the Android SDK, the Android tools, and the particular version of Android you want to compile against. There's also, if you use Gradle, there's now a nice Gradle plugin called Android SDK Manager, which can also help you with this. So those are the prerequisites. So let's take a look at the steps required to actually build an app itself. So firstly, there are two official build systems from the Android tools team. Ant is the one that's been there from the very start. But for well over a year, I think, there's been a Gradle build system in the works. It's pretty much at a 1.0 state now, but it's not quite, I think, the official one yet. However, Google's development conference, Google I/O, is starting today in San Francisco, so hopefully they'll make some nice announcements, but also not make too much of this talk redundant. So when you check out a repository, of course you need to get your code, and the Android emulator plugin provides this build step, which is called create Android build files, or create and update Android build files. So what this will do for you is search through your workspace and detect what Android version you want to compile against. If this is not installed already, it will go to the web, it will download the installer, it will install everything on your build slave for you. And if you say this app needs to be compiled against Android 4.2, it will then download Android 4.2, and that's pretty much it. Then, since it's an Ant build, of course you can just use the built-in invoke Ant task, and it will compile your code. It will build an APK file, this Android app, and that's pretty much it. It's very similar for Gradle. So as I mentioned, there's this really nice Gradle plugin called Android SDK Manager, which will automate a lot of this stuff for you without having to use these Jenkins build steps. And aside from that, it's pretty much the same. So you run the Gradle wrapper, Gradle will be downloaded and installed as normal. The Android SDK will be installed, and again, we have a complete app. So if I can switch to my other screen, which could be a challenge, we can take a look at how this works. So firstly, I should mention, to demonstrate this, I wrote an enterprise app which is called Awesome Dogs. And this is a typical, well, it's a very simple app. It's essentially a list showing some static data, and these are essentially dogs somewhere in my family or extended family. So I have a static database, I have a list screen, I have some showing downloading a thumbnail from the internet, and if I click on one of these items, you get an overview, you get some information, it's parsing this information, downloading the image, this kind of typical stuff. So what I've also done is written a set of test cases that test, okay, when I click on this, does it show this screen? Is this data formatted correctly? All that kind of stuff. So if we then look in Jenkins, I have my Jenkins instance over here. So I have this project called App Build, which, as you can imagine, does the steps I just talked about. So I'm checking it from a local Git repository, and then all I am doing is exactly what I said before. So create Android build files. I'm running clean and debug from Ant, and I'm running this against the test build file. So that will build first the dependent app, and then it'll run the test. It'll build the test suite. So at the end of this process, I'll end up with 2 Android APK files. Then I run the Android lint tool, which is something that's been built into the SDK for a couple of years now. And lint is a great little tool that will search through all of your source code, all of your Android resources, and tell you if you've made any small programming errors or if you've introduced some sort of subtle bug. So that's really helpful. But it can produce an XML output file, and there's a Jenkins plugin which will then parse that and show you a nice report, see how many issues you've added, or potentially you can also fail the build if you've added too many failures or if you've added fatal issues. And then, as I say, you just publish this lint report. As always, it's a good practice to archive your artifacts, and then we have this test project, which we'll talk about later. So if I go up and build now, we will see up at the very top, checking it from Git, and then we see exactly what we're talking about. So Jenkins will automate this for us. It will search through our workspace for any Android projects. It will say, okay, I found some. Do you need Android 16, which is Android 4.1? Create the build files, and then the rest is just normal Ant stuff until we get down to the bottom. Build successful. Then we run lint at the bottom and show the results. So if we look at our build page, it finished already in a few seconds. I can't see that on the right. But yeah, so it's created our artifacts here, and we see in lint there were 8 issues. So if we click on this, we get the standard static analysis report that we're used to in Jenkins. But for our Android project, if I click here on details, I can scroll down and see stuff like, okay, I didn't actually set an icon for the app. It's just used some generic icon. So I can click on this and see exactly in context where the error is, and I can hover over this and see, okay, that's the error. That kind of stuff. So pretty simple to get set up. Just to build an app in a clean environment and do some basic tests. So, as touched on, building our app is good, but of course we need to do some testing to make sure we have a stable app. So in Android, there are a few different possibilities of where you can run your tests. You can run your tests on a JVM. For example, if you have business logic, that's just basic Java. Also, there's a really nice project called Roboelectric, which lets you run tests on the JVM without having to do all of this packaging and installing onto an emulator and this kind of stuff. And this, while it's very fast to run, there's also trade-offs in that it's not a full Android device, of course, and it doesn't implement all of the Android APKs. It just implements part of them, but you can get quite far, and it makes your tests a lot faster. Of course, you can also run on an emulator. This has its more pluses and negatives. So the positives are this is a real Android operating system that's running. It's not a simulator, it's really an emulator. It's running simulating an ARM processor or an x86 processor. It's running the real Android APIs. However, the downside is it's a bit slower. It's got a bit of a reputation for being very slow to start up in some cases. That's been somewhat improved over the years. But also the other downside is while you can emulate different operating system versions, screen sizes, different hardware properties like RAM, GPS, keyboard, whatever. The downside is, what's the downside? What was I going to say? The downside is, of course, it's not as real as a real device. And if you want to test things like gyroscope and other physical sensors, you're not going to get quite as far with an emulator. And of course, at the end of the scale, there's the real device. You can't get much more real than a real Android device for testing. However, this has its other trade-offs. So while it is running at the normal speed you could expect your app to run at, it's running on the genuine hardware, software, everything's there. You've got access to sensors, but at the same time, if you're wanting to automate this, you can't really do too much with moving the sensors around unless you build some sort of test robot, which people have done, and it's quite interesting. But also you have the difficulties of you have to have a real device physically plugged into your Jenkins server somewhere, and then there's a bunch of issues that go wrong. So USB connections can be flaky, especially with this Android debug bridge that we have. And also making sure that your device is always in a clean state for every build. So stuff like that can be a bit tricky. So there's trade-offs, there's pluses and minuses for these different approaches. But regardless of which approach you choose, we first need to write and then, of course, execute the tests. So there are projects like Roboelectric, Espresso, what's there? So that's Robotium, for example. And these are all essentially running under JUnit 3 or JUnit 4 test runners. And built into Android. However, the default Android test runner doesn't output JUnit XML, which on the Jenkins side of things would be pretty handy because we have JUnit support built in. Of course, we have the XUnit plugin. So essentially, if you can get Android to output one of these formats that's known to Jenkins, it can parse your test results and show a nice report to you. What I normally do, and what's also built into the new Gradle test runner, is to use, there's an open source project which implements the JUnit XML for Android. It's called, I think it's just called JUnit test runner, something like that. So if you build that in to your app, every time you run your test, you'll get a nice JUnit XML, and then you can get Jenkins to parse that for you, and you get the usual nice looking test reports, and you can fail the job if there's too many failures, or you'll get the yellow and red and this kind of stuff. Okay, so how do we actually go about implementing this in Jenkins? So there's a checkbox from the Android emulator plugin, which is called Run an Android emulator during build. So this lets you enter the parameters you want for the emulator. You can say, I want an Android 4.2 device with a 500 megabyte SD card. I want it set to British English or German or whatever. And it should have a GPS, and it should not have a 3G modem. It should just be Wi-Fi only, for example. Jenkins will then create that emulator for you on the fly at the start of your job. It will start it up. It will wait for it to finish starting up, and then it will start archiving all of the log output to disk. Once that's done, your build steps will start running. So here, the second build step. The second step is, of course, to use the copy artifact plugin. We copy our APKs we built in this previous job, copy them into the workspace. Then there's another Android build step called install Android package, and that will do what it says onto the running emulator. And then, of course, you can just run an execute shell or run some sort of script that will tell Android, please run the test I have just installed. In this case, it's called the instrument command. Run that on the Android emulator shell, and that's it. So then you just grab the XML from the device or from the standard output and give that to Jenkins. So that helps us to see our test results in Jenkins, mark the build as unstable or failing or whatever as appropriate. But how does this affect, or how does this help us with this problem of this 3,500 different devices? Well, we can use the power of the matrix job or the multi-configuration job in Jenkins. So this lets you run the basic same job configuration, but with some variables. So as Android developers, the most important variables to us are Android version, so the screen size or the screen density that you want to test, locale, so which languages you're going to support. So while this doesn't quite equal 3,500 different device models, it covers the majority of what combinations are in use in the real world. And of course, you can change the parameters here, change the axes based on what your user base expects. So maybe you only support 2 languages, or maybe you support 8 languages or whatever. Maybe you don't support these older LDPI small screen devices, for example. So you can set up a matrix of what makes sense to you. Generally, I would test the minimum supported Android version and the maximum one. You don't necessarily need to go through all the ones in the middle, but whatever is important to you. The nice thing about using a matrix job with the emulator is it really helps to find some subtle bugs. So personally, I found a lot of bugs that I would never have found through manual testing, just because of the sheer number of combinations that there are out there. So for example, sometimes I've mistyped an ID in one of my German layout files, for example, or I've forgotten a string parameter in one of the languages or one of the screen sizes, and that will cause a crash at runtime. Lint can help with this and give you some hints, but it doesn't catch absolutely everything. There are also some really, really subtle bugs which I've caught using this approach. For example, something that's not super well documented is that Android comes with a different version of SQLite, the built-in SQL database, with different Android versions. And this can bring different levels levels of functionalities, different SQL language support, different function support, for example. So I once wrote an app where it was a relatively complex SQL join statement, and I was testing this on my device and on my emulator, and everything was great. And then I send it off to Jenkins, and then all of a sudden one of these columns was just completely yellow. It turned out that some SQL syntax I had used wasn't supported on Android 2.1 or something like that. So that's pretty helpful. So again, we can just take a quick demo. If I can get my browser back. So here I have Android test, and I can build this now, and we can look at the configuration while it builds. So as we saw before, I'm running this as a downstream job. So this says as soon as the app builds and has been compiled successfully, start running the tests. And then I've got my version. So here I've chosen I want to test Android version 1.6, which is pretty old, but I also want to test the newest one, Android 4.4, and one in between. And I'm supporting 2 different languages here. So Jenkins will then create these 3 times 2, 6 different builds for us. And so here's the main part. So here's we're saying, okay, I want to create an Android emulator for each of these builds. And here we can use the variables we've defined above. So here we're saying OS version is one of these 3 options from above. For this test, we're keeping the screen size, density, and resolution constant. But we're saying, okay, we want the German version or we want the British English version. And then beyond that, it's just pretty standard Jenkins stuff. So using copy artifacts, which is always a good practice, to copy the APK files we built in the previous job. Use the Android install packages step to install the 2 packages onto the emulator that's now running. And then just standard Android ADB shell. So this is running this JUnit test runner over here. And at the end, we pull the XML report from the device. And I don't know if you can see that, but down at the bottom, we're then just running the JUnit test analysis on that. The other nice thing about the Matrix job or the emulator plugin itself is even though I'm running multiple emulators, and they're running in the background just now on my laptop here, even though I'm running ADB shell, normally Android would say, okay, you're running multiple emulators, which one do you want to install on? But what the plugin does for you is isolates each job, each emulator in a single process. So, for example, if one emulator crashes or if the debug bridge crashes, it won't bring down all of the parallel jobs. Also, if 2 jobs try to use the same emulator configuration at the same time, there's some locking involved, so it'll automatically wait for one job to be finished with the emulator before the other one can come in. But by now, after a lot of time, this job should be finished, and it took, I can't see that, but up in the corner, I think it's 2 minutes it takes to run 6 different, to start up, run the tests, and shut down and do all the logging and analysis for 6 different jobs, for 6 different configurations, so that's not too bad. However, what we can see here already is there's a bit of an irregularity, so all of the 1.6 builds are somehow unstable, they've gone yellow, but also all of the German builds have gone yellow, which, thanks to my slightly contrived test cases, we can see what happened. So here, for example, we can see German and German. These both failed in test format weight. So on this dog detail screen, it was showing the weight of the dog for some reason. And as you can see from this very, very clear JUnit output, we were expecting a decimal point, but actually we've got a decimal comma because it was running on a German emulator. So we can see that I've made some sort of programming mistake in assuming that users are always running their devices in English, which of course isn't the case. And if we go back to the results, we can see, so that explains the German thing. So the OS 1.6, what was going on there? Okay, so we have 2 different tests failing here. Test clicking an item opens the details. Okay, so here we're getting a Java Lang verify error, which normally in this context means I've been trying to use an API that's not available in this Android version. So we see that this happened for the two Android 1.6 versions, and indeed, I wrote a piece of code. I tried to use string.isEmpty, which isn't actually available until Android 2.2 for some reason. Yeah, so pretty quickly, just triggered by a single commit, we've built our app, and we've gone through 6 different configurations, and we've got feedback straight away. So that's pretty nice. Are we back? We're back. So, what else can we do in terms of testing? So there's this tool called Monkey in the Android SDK, and what Monkey does, it's essentially a stress testing tool. Or, I mean, to look at the documentation, it says, to be more accurate, it generates a pseudo-random stream of events, which could be anything. It could be tapping on the screen, it could be scrolling, it could be pressing the volume button, it could be rotating the screen, this kind of stuff. But this basically runs as fast as it can, putting random input into your app to see if you can kind of crash it. So this is a really great stress test for your application. So maybe you've got subtle errors that are caused by some, for example, if you're building your app with ProGuard and you're doing a lot of bytecode optimization or obfuscation, sometimes your ProGuard configuration, you've forgotten to exclude some classes from being removed, and you'll cause a crash somewhere. Because you're always running your app in debug mode during the day, you're not always doing it in release mode because it's too slow, there could be errors in there that you don't catch. So one thing you can do is to run this Monkey stress test, for example, nightly. So here, what I often do is run a stress test nightly. So I say, Monkey, please just send random events to my app for half an hour or whatever. I run this once per night. So this is really easy to do with the pull SCM changes. You just set this to midnight or daily or whatever. So the job only runs, it doesn't run every day because there's no need for it to run every day. It only runs if there are changes during the day. So that's quite helpful. So then, of course, you just install the application. You start the emulator, install the application, and then there's a build step, which will start this Monkey tester. So all you say is, here's my app I want to run against. I want to run 5,000 events or 50,000, 100,000, whatever. And that's it. It'll start running away, start going crazy on your app, and the whole time it's logging what it's doing. So Monkey will run against your application in the emulator. We have this event log that's written to the build workspace, so we know exactly what the Monkey has done. So it's reproducible later. So if you find a crash later, you can look through the log and see exactly what happened. And then we have this Android, as a post-build action, we have this publish Android Monkey test. So this will analyze this event log, look for any crashes, and then you get a nice badge on your build screen that says Monkey passed or Monkey failed. So any crashes can mark the build as unstable or failed or whatever. Okay, so we have built an app, we've tested it, we've stress tested it, and we're pretty much ready for launch. So how do we actually go about getting the app into the hands of users, whether that's your QA department or just curious product managers, or maybe you have a list of beta testers or whatever. So there are various ways we can get an APK from Jenkins. So the most basic and simple stuff is uploading your app to a server somewhere and telling people to download it. This isn't really ideal because users have to go through some manual steps in the settings of their Android app. They have to download it, they have to install it. There are also third-party solutions like Hockey App or Test Fairy is one apparently. And these have Jenkins plugins. So Hockey App is what we use a lot. So this will essentially allow you to upload an app to Hockey App. This will then notify all of the beta testers that have the app installed, hey, there's a new version available, and they open the app. And they just have to click update, and that's it. So it's for the user, it's very simple. And for us, it's very simple to upload. It's directly integrated into Jenkins. And also we then get crash reports and usage reports and all of this kind of stuff. So it's pretty nice. Hopefully, at some point, there might be a Google Play API for this. So Google Play also provides an alpha and beta testing service. However, it's not really acceptable that I know of. So there's no official API for it. It's also very slow. If you upload an app and say, okay, I want this to be released to my beta testers, you've got to wait then about 2 hours before it's actually live. Whereas with Hockey App and whatever, it's instant. So maybe something else will come out of Google I/O. We'll see. So how do we actually go about triggering a deployment? So the basic option is, well, it compiles, ship it. So every successful build just gets sent to Hockey App or to your beta testers, however. Of course, there's manual. You can just say, okay, I think it's now ready to send to my testers or QA department, build now. Then there's SCM triggered. So this is what we do at Iosphere a lot. So we have job configurations that check if you've pushed to a tag that's called alpha slash whatever or beta slash whatever, it will then build an alpha version or a beta version of the app, upload it to Hockey App, and distribute it to our users. And then the final point here is build promotion. So build promotion is a nice plugin which lets you add some manual steps or various steps into your Jenkins process. You can require that someone from your QA department first has to manually test it on their device. Then they come into Jenkins and click a button that says, okay, this is great. I'm ready. Go for it. Upload it. So about actually building a release itself. So there's a code signing requirement it's pretty simple really. So Android apps are signed by default. For debug versions, they're signed by a key that's essentially for each developer is random pretty much. Generated randomly the first time you use the Android SDK. So what we do is we use the slave setup plugin to make sure that this debug key, this Java key store, is consistent across all of our slaves, so that no matter who builds an app on their developer machine, or if you build it on Jenkins, you can install it on any device, because otherwise you start getting conflicts saying, if you try to take a build that was an app that was built on one developer's machine and install it on a device, then you try to install an app installed on another developer's machine, you'll get this notification saying, no, these signatures are inconsistent. So what we do is remove this inconsistency, make sure we use the same debug key store across all of our slaves. And also we do this for the developers as well. You can also use the envinject plugin to inject the key store password into your build. So envinject is a great plugin which has, among other things, this password feature where you can say, okay, I want to have my secret password. I'll type it in once into this password field. I'm not going to commit it into source control. My users will never see it. My Jenkins users won't see it. And it just exports an environment variable. You can then pick up that environment variable in your Ant script or your Gradle build. Of course, you should archive the artifacts. So you've got a copy of the build you just built. And of course, the ProGuard mapping file. So if you've used ProGuard to obfuscate your code, this creates a mapping file that says, if there's a crash and the stack trace just says a.b.c, this then turns that into something like string java.util.collection or whatever. So it's really important to archive that file. And of course, build should be traceable, build should be identifiable. Of course, you should use Git to tag it. Android requires that you have this version code parameter, which is just an integer that you have to increment every time you create a new build. And we can take advantage of the build number variable in Jenkins to automate this for us. So if we take a look at, so this is part of the Gradle configuration file that I use for building Android apps. So here above, I set two variables for major and minor versions. So I'm building app version 1.1 here. And then we've got these two properties called version name and version code. And instead of those just being static strings or static numbers, I have a method that computes these dynamically at build time. So here, so for compute version name, I'm saying, well, it's just x.y. It's pretty simple. But I don't know if you can see that at the bottom, everyone. But compute version code, it takes this major version and minor version, and then it also takes the system.env.build number, this build number environment variable that Jenkins sets for every single build, and I add that on at the end. So for build number 9 from Jenkins, I would get this 11009 that you see down there. build number. So this version code is pretty much hidden. It's not, the user doesn't really see this anywhere. Developers can see this, but also to make it a bit more meaningful for the user. So if your customer is testing your app and you say, which version are you using? And they'll say, I don't know. I'm using a beta. Okay, which beta? So for example, here in the version name, we can say, okay, B for beta, and then we can add the number, this build number. So they can say, okay, I'm using 1.1 beta 9. And you can say, okay, I know that's built Jenkins build 9. I know exactly which Git tag that is. I know exactly which version of the code they're running on their device right now. So after all of this, we have an APK we can upload to Google Play or testing service or whatever. And here we see their app is in production. It's version 1.1. We see this 11009. So instantly I can see, just from looking at the Google Play console, the version that's live in the App Store right now, version 1.1, and I know it was built from Jenkins job number 9, Jenkins build number 9, and then I can go right back and see exactly where it came from. So that's pretty cool. While we're looking at the Google Play upload interface, one last thing you can automate with Jenkins is to use matrix jobs and emulators to automatically create the app screenshots that you need to upload here. So normally you need to upload at least 2 screenshots for your application. Preferably you should do this for every language. So one app, for example, this app that I worked on had, I think 6 screenshots times 7 different languages. So doing that manually is pretty painful. 42 different screenshots, it's not really what I want to spend my time doing. So Jenkins can help with this. I just created a pretty small test job that set up different scenarios. So it said the first time, open the home screen, take a screenshot. Open this details page, scroll down, take a screenshot. Click on the third result, swipe across, take a screenshot, and so on. And then it archive the artifacts of these with the language name and a screenshot identifier, screenshot name, home page, detail page, whatever, and that's it. So I just click build now, wait 5 minutes, it's done. And then I can just upload it to Google Play. So that's pretty cool. Yeah, so that's essentially it. So talking about the whole process, here's an overview. So we go from pushing our code from our computer into our Git repository. Jenkins, of course, will then take this from us, build it. We're doing different tests. We're doing stress tests. Optionally, we can push this to QA, get the approval. Then we're automatically deploying it. And then it ends up in the hands of our end users. But the only part of this that's manual, and the way that we do it, is the initial push. All we do is git tag, beta or release or whatever. Okay, not release, but alpha or beta. Git tag, git push, that's it. It's done. The app is in the hands of our users, so that's pretty cool. So everything is pretty automated. So that's pretty much it for now. So if you found this interesting, or you just really enjoy Scottish accent for some reason, I'm also giving the final talk of the day, which is a lightning talk about some of the Git stuff I talked about here, building from different Git tags, and also maybe some hints about Git plugins and Jenkins.